Number 42 here is asking us to find min and max values of the function on this interval by looking, of course, at critical points and endpoints. So we have our two endpoints right here. Let's find some critical points. So let's take our derivative here, dy dx, and this is going to be loads of fun. Probably should have rewritten y as 2 times an x squared plus 1 to the 1/2 power minus x. That makes it easier to differentiate. So using the power rule, the 1/2 times the 2 is just a 1. Same base now, x squared plus 1. Drop that power by 1, so that's a negative 1/2 power, and then times the derivative within, which is going to be a 2x. And then a minus, derivative of that x at the end, is just going to be a 1. So that's where we are right now. And if I have to actually do any work with this, like find out where it's equal to 0 or undefined, it would probably benefit us to rewrite that first term right there as a 2x on top all over the square root of x squared plus 1. Now there's still a minus 1 at the end of all that. Okay, so this is where we'd want to stop and say, okay, is this derivative ever going to equal 0 or be undefined? I actually think we're in the clear on this thing being undefined. We're squaring x before we do anything else here, guys, which is going to guarantee a non-negative result. It's going to be 0 at the minimum, but then you're going to add 1 to that. So the minimum value of your radicand will be 1. We're not going to have to worry about taking the square root of 0 or the square root of a negative. So I don't think we're going to be undefined here at all, but I do think it's possible that this derivative might equal 0. So let's work on that. I'm going to bring that 1 to the right side. So 2x over the square root of x squared plus 1 would equal 1. And now I would multiply this denominator here over to the right side here. So that's going to leave us with a 2x is equal to the square root of x squared plus 1. Let's get rid of that nasty radical by squaring both sides. So the left side times itself is going to be a 4x squared. That'll equal x squared plus 1. That'll give us, let's see, 3x squared is equal to 1. X squared is equal to 1/3. And x then would equal plus or minus the square root of 1/3. So there's two critical points we got here. However, looking at our domain from 0 to 2, I can throw out the negative and just focus on the positive square root of 1/3 there. So right here, we have our two endpoints. Here, this is the one and only critical point that we got inside this domain. So now, I think it's time to go ahead and start evaluating this function, y, at our left endpoint, which is 0, at our one critical point, which was the square root of 1/3, and then at our right endpoint, which is 2. And that's what we've got right here. So plugging the 0 in, that's a 0 plus 1 is 1. The square root of 1 is 1 times 2 is 2. Minus 0 is going to get you 2 for that y value right there. Let's see. Plugging in the 2, that's a 4 plus 1, 5. So it's 2 times the square root of 5, and then a minus 2 at the end of all that. So let's see, the square root of 5 is roughly probably 2.2, something like that. So 2 times 2.2 is about 4.4, minus 2 is about 2.4. This one, well, I don't know. Let's see. The square root of 1/3 squared is just 1/3. 1/3 plus 1 is 4/3. This isn't as bad as I thought. The square root of 4/3, square root of 4 over the square root of 3. So that's 2 over root 3 times 2. That's going to be 4 over the square root of 3, and then minus, okay, this isn't cool, the square root of 1/3, which is 1 over root 3, which ends up being 3 over the square root of 3, which, if I recall from trig here, guys, that's a value we've seen before. That's just the square root of 3. Which is about 1.732. Okay, I thought I was going to need a calculator for that, but I guess I was able to get it. Assuming that I'm right, if we take a look at these three y values right here, we can tell that this one down here on the bottom, this value of 2 root 5 minus 2 looks like the largest of all of those. So there is your maximum value. And then this ugly value right here is going to be the minimum. So I'm going to leave that the way it was. That's really just the square root of 3 is what I've learned right there. So minimum, and I'd probably write that as root 3. And they didn't ask for it, but this value right here, we started off at a y value of 2 and then immediately went down. What we're dealing with right here then, guys, is a relative maximum. But once again, when the directions just say find the minimum and maximum, they're talking about absolute min and absolute max. So that's what we have in the two boxes, and those are the answers to number 42.